So question 5.1 goes as follows. If 5 cosine theta minus 3 equals to 0, such that theta is greater than 180 degrees but less than 360 degrees, and 17 sine alpha equals to 8, such that alpha is greater than 90 degrees but less than 270 degrees. Determine, without the use of a calculator, the value of tan alpha plus tan theta. So to answer this question, the first thing that we are going to do is to take down 5 cosine theta minus 3 equals to 0. And then we are going to manipulate this equation to make cosine theta the subject of the equation. So the first thing that we're going to do, we are going to transpose negative 3 to the other side. Thereafter, we are going to divide by 5 on both sides of the equation to get 3 over 5. Secondly, we need to draw a Cartesian plane. Now, we are gonna label the axes of this Cartesian plane, starting from the positive x-axis with their respective angles. So by convention, we label the positive x-axis as the 0 degrees point. Therefore, the positive y-axis are going to be at 90 degrees, which means that the negative x-axis are at 180 degrees, while the negative y-axis are at 270 degrees. And then when we return to the positive x-axis, we have 360 degrees, therefore a full revolution. Okay? And now, in addition to this, you must also remember that a Cartesian plane is divided into 4 quadrants. And we call this the first quadrant, this is the second quadrant, and then here we've got a third quadrant, and then lastly, this is our fourth quadrant. And now, in addition to this, you must also remember that all students take a calculator, which means that in the first quadrant, all trigonometric ratios are positive. In the second quadrant, only the sine ratio is positive, while in the third quadrant, it's only the tangent ratio that is positive, and lastly, in the fourth quadrant, it's the cosine ratio that is positive. Okay? And now, another important thing to remember is from the basics of trigonometry, which is SOHCAHTOA. As you may already know, this means that in a right-angled triangle, the sine ratio is defined as the opposite over hypotenuse, the cosine ratio is the adjacent over the hypotenuse, and the tangent ratio is equal to the opposite over the adjacent side. Okay, so using all of this information, we are now going to consider the restriction of theta that they had given us in the statement. So we were told that theta is greater than 180 degrees but less than 360 degrees. So this means that the angle of theta is in between 180 degrees and 360 degrees, which basically means that it's either in the third quadrant or the fourth quadrant. Now, this is a very important piece of information because it's telling us that a right-angled triangle that would correspond to this equation of cosine theta would either be in the third quadrant or the fourth quadrant. Now, to decide whether which one exactly between these two quadrants, we need to go back to our cosine equation. So here we can see that cosine theta is equal to positive 3 over 5. So cosine theta is positive. Now, between the third quadrant and the fourth quadrant, as we had already indicated, cosine is positive in the fourth quadrant. So the right-angled triangle that we are going to draw will be in the fourth quadrant. And this is how we are going to draw it. We just need to draw a line from the origin, and then we must make this a right-angled triangle by drawing a line that will be perpendicular to the positive x-axis. And so this is going to be our 90 degrees angle. Okay, and now we are going to choose this angle to represent theta. After this, we need to now make sure that we label all the sides of this right-angled triangle. And we're going to use our cosine ratio here to do that. We know that cosine is the adjacent over the hypotenuse. So this means that 3 here is the adjacent side, while 5 is the hypotenuse side. Therefore, relative to this angle of theta, this side here is obviously the adjacent side, so we can label it with 3. And we know that the hypotenuse side is always the side that is opposite to the angle of 90 degrees. So this is our hypotenuse side, and it's equal to 5. And now we need to work out the opposite side. And to do that, we can just use the Pythagoras theorem. So from Pythagoras theorem, we know that the hypotenuse side squared is equal to the square of the other two sides. And in this case, we can call them the adjacent side and the opposite side. And so this will be equal to 5 squared equal to 3 squared plus the opposite side squared. And 5 squared is equal to 25, while 3 squared is equal to 9. So we need to transpose 9 to the left-hand side, and that will give us 16 equal to O squared. And then we just need to square both sides of the equation to get 4 equals to the opposite side. So the opposite side is equal to 4 units. Okay? And so we are done with the cosine ratio. Now let's move on to the sine ratio and follow the exact same steps. So in this case, we have 17 sine alpha equals to 8. So even here, we need to make sine alpha the subject of the equation. So we will have sine alpha equal to 8 over 17. And now, taking into consideration the restriction of alpha that they have given us. So alpha is between 90 degrees and 270 degrees. So if alpha is between 90 degrees and 270 degrees, it means that it's between the second quadrant or the third quadrant. And now going to the sine equation that we have here, we can say that sine alpha equals to positive 8 over 17. So it's positive, meaning that between these two quadrants, we're going to choose the quadrant whereby the sine ratio is positive. Therefore, that will be the second quadrant. Okay? And so that is exactly where we are going to draw a right-angled triangle to represent this ratio. So likewise, even here, we need to draw a line from the origin like that, and then we must have a line that will be perpendicular to the x-axis. So always, whenever you are drawing a right-angled triangle in the Cartesian plane, for the purpose of answering a question like this, the 90 degrees angle should be along the x-axis. So there it is in this case. Therefore, this will be our right angle. Okay? And likewise, the angle is always between the hypotenuse side and the x-axis. So this will be our alpha in this case. And now we know that the sine is equal to the opposite over the hypotenuse. So the side that is opposite our angle of alpha here, there it is. So this side will be equal to 8. And obviously, this is the hypotenuse side, so it will be 17. And now we need to work out the adjacent side. And we can just quickly apply the Pythagoras theorem. So the hypotenuse side squared is going to be equal to the opposite side squared plus the adjacent side squared. Therefore, the adjacent side is going to equal to the square root of 17 squared minus 8 squared. And you can just punch this into your calculator and you'll get a value equal to 15. So the adjacent side here is equal to 15. And now that we have analyzed all the information that they gave us in this way, we can be able to answer any question that is related to this. So in this case, we are required to determine the value of tan alpha plus tan theta. So this is going to be pretty much straightforward. So tan alpha plus tan theta is going to be equal to, so just remember that the tangent ratio is equal to the opposite over the adjacent. So for tan alpha, we need to go into the right angled triangle that has alpha. So here we can see that the opposite side is equal to 8, while the adjacent side is equal to 15. So tan alpha is going to be 8 over 15. However, you must note that tan alpha is in the second quadrant. And in the second quadrant, tan is negative because the only ratio that is positive is sine. Okay? Let me repeat this because it's very important. And this is exactly where most students make a mistake. You mustn't forget to consider the sign of the trig ratio because we have specifically drawn these right-angled triangles in these quadrants for a reason. So as I was saying, in this case, we can say that this right-angled triangle for tan alpha is in the second quadrant. And in the second quadrant, only the sine ratio is positive. Therefore, the tangent ratio is negative. So the 8 over 15 that we have determined must have a negative sign. Similarly, for tan theta, we can see that there is a right-angled triangle with theta in the fourth quadrant. And even in the fourth quadrant, the tan ratio is negative because only the cosine ratio is positive in this quadrant. So we will have a negative sign here. And now we can go ahead and determine the actual value of tan theta. And again, tan is the opposite over adjacent. So there is our opposite and there is our adjacent. So this will be equal to 4 over 3. And so, although you are not allowed to use a calculator, you can freely use it from this step. And so this would give you negative 28 over 15. But you must just leave your answer like this as a fraction. Obviously, because you are not using a calculator. Okay, so that is basically how you can go about answering this particular question, and you can also apply the same thinking process in other similar questions. Okay, see you on the next one.